Well, here we've got an equation with two radicals in it. The main idea is to isolate a radical and then square both sides of the equation, because squaring is the opposite operation of square root. So I'm going to leave this one where it is, and I'll take this one and add it to the other side. So we've got the square root of 2x minus 1 is equal to a 2 plus the square root of x minus 4. Now that one of the radicals is isolated, square both sides. Well, on the left-hand side, squaring the radical will eliminate the radical, leaving a 2x minus 1. On the right-hand side, we need to multiply this by itself using FOIL or the distributive property, or you can use the shortcut that you square the first item, leave some space, square the second item, and in the middle you multiply the two and double the result. So it would be a 4 and then square root of x minus 4. Now the fun part with this one is there's still a radical, so we need to take all of these other terms, move them to the left hand side, and then square again. So one thing to notice is that these two cancel each other out, a positive 4 and a negative 4. So we just need to subtract x from both sides, leaving an x minus 1 equals 4 and the square root of x minus 4. And at this point we've got a choice. You can square both sides of the equation. This would become a 16 and this radical would be eliminated. Or you can divide by 4 and then square both sides. Well, dividing by 4 would introduce fractions over here, which is alright, but for right now I feel like I'm just going to square both sides right now. So on this side, as I said, it's going to become a 16 and an x minus 4. Well, the 16 needs to be multiplied with all of that, so put the x minus 4 in parentheses. And over here, again, FOIL or use the distributive property, or square the first item, square the second one, multiply the two, and double the result, negative 2x. Next, we're going to distribute the 16, so it's going to be a 16x minus 64. And let me just recopy this side. And then subtract 16x from both sides. And also add 64 to both sides, so that we've got everything set equal to 0. And now combine like terms. So x squared minus 18x plus 65. And we're not able to reduce or divide anything out, so we'll use the quadratic formula. X is equal to negative b plus or minus the square root b squared minus 4 times a times c, all divided by 2 times the a. And let's see, we've got inside the radical there is negative 18 squared minus 4 times a 65. A 64. Wow, that worked out nicely. Because then we can take the square root of that answer. That square root of 64 works out very nicely. So we've got x is equal to a positive 18 plus or minus the square root of 64, which is 8, and then divided by 2. So that gives us a couple of possibilities. There's that x equals an 18 plus an 8 divided by 2, which is going to be 26 divided by 2, or 13. There's also the possibility that x is equal to 18 minus 8, and then divided by 2, which is 10 divided by 2, or 5. Well, when we squared both sides, which is a legal algebra operation, when we squared both sides, it's possible that we introduced an extra answer that's really not a part of the solution. So what I now need to do is check and make sure both these are correct. I'm going to use the graphing calculator to check. I'll graph the original problem. Y is equal to, in the original problem, square root of 2x minus 1 minus the square root of x minus 4. And when does that equal a 2? Now, I need the x to go out to at least 13, so I'm going to change the window and have the x go from, well, 0 to 20 should do it, since we're looking for the answers of 13 and 5. And then go to the graph. There goes one of the functions, the square root function, and then there goes the 2. So it looks like somewhere in here they're intersecting, and in this area I really need to zoom in, so I need to change the y values. So if I take a look at the graph and trace it, you can see the y values are approximately 2. Go back to the window and have the y values stay around 2. So maybe from 1 to 3 would do it. Let's take a look. So there goes the graph. Looks sort of like a Nike swoop. Ah, that's better. So then we can see there are 2 places where they intersect. So this one should be where x is equal to 5. Trace and put in a 5 for x. Yes, that one's right. And trace and try 13. That's right. So both answers are correct. So we keep both of those as the 2 possible x values.